In this lesson, we're going to look at multiplication. So we're going to focus on firstly the multiplication algorithm, which is that process we use for doing long multiplication. And then we're going to look at a couple of mental multiplication techniques. Okay, so we'll start with the algorithm because that's a thing that you'll already know quite well. Okay, so if you remember the algorithm or you don't, we're going to go back through it really quickly now. Now, it's a little bit more complex than the addition-subtraction algorithms, and what I'll do is I'll set up a question over here to the right. So let's say 134 multiplied by 23, and we'll follow this through and we'll work it out. The first step in the multiplication algorithm is to multiply each number in row 1, so obviously this is row 1, by the ones value in row 2. Now there's a little bit of an extra here, and it is carry any tens value to the next column. Okay, so we'll go through that. This is something we've done a lot, I assume. 4 times 3 is 12, so the 2 goes here, and we carry the 1. We then look at that 3 by 3. So 3 times 3 is 9 plus the 1. So that value we carry, we're going to add on. So plus 1 gives us 10. So we're left with 0. And we carry the 1. And now our last one is 3 times 1 is 3. Plus 1 is 4. Okay, so that's the first thing we do in our multiplication algorithm. We multiply each number in row 1 by the ones value in row 2. Okay, so step 2 is if there is a tens value in row 2, then we add a 0 in the ones column. So we put our 0 here, then multiply each value in row 1 by the value in the tens column of row 2. Okay, so this is our value that we're talking about, our 2. So we have 2 times 4, which is 8. Of course, if there is any carry-on values, we have to carry it. So carry any tens value, just like before. Let's get rid of these. So cross them out. We know that they're not important. 2 times 3 is 6. 2 times 1 is 2. Now, of course, if there's a number in the hundreds, we'll have to do the same thing. So we want to repeat process for number in 100s column and so on. So we could make this as long as we like. And the last step is that we want to add the totals. So I'll add these up now. 2 plus 0 is 2. 0 plus 8 is 8. 4 plus 6 is 10. So we can carry the 1. 1 plus 2 is 3. Now, like I said before, the multiplication algorithm is a little bit more complex. There's lots of things going on and lots of things that you have to remember. I've tried to simplify the algorithm as much as possible, but the best way to do this is practice. And if you don't know your times tables, the biggest thing you need to do is practice your times tables. The better you know your times tables, the quicker you can go with each of the individual things. And then the algorithm just becomes about remembering the steps instead of trying to work out what 8 times 6 is equal to, for example. Okay, we'll go through a couple more examples, and then I'm going to get you to pause it and go through a couple yourself. So I'm going to move up, and let's make up 2 examples. Let's say 527 multiplied by 32. And we'll also do 1,243 multiplied by 123. So let's do a mean one. All right, so let's start with the first one. We've got 2 lines that we need because we've got a number in the ones and the tens. So we'll have to be adding up 2 numbers here. And let's go. So we'll start with the ones. So 2 times 7 is 14. Carry the 1. 2 times 2 is 4, plus 1 is 5. And then 2 times 5 is 10. We got no way to carry that 1, so we'll just write the 10. So we've got 1054. Now we're on to our tens column, so we start by writing a 0 there. And we've got 3 times 7, which is 21. So we put the 1 here. Let's get rid of this 1. It's no longer useful to us. And we make 2 there, so we carry the 2. 21, we put the 1, carry the 2. 3 times 2 is 6. Plus we add on our 2, that gives us 8. And then finally 3 times 5. We've got nowhere to carry the 1 because 3 times 5 is 15. So we write our 15 here. We can now add this together, and we've got 4, 6, 8, 6, and 1. So that means our answer is 16,864. All right. Now the next one, a little bit scarier. We're multiplying by 123. So that means we should have 1, 2, 3 lines that we're going to add together. All right, so let's start in the ones column. 3 times 3 is 9. Nice and easy, no carrying. 3 times 4 is 12. So we put the 2 here, carry the 1. 3 times 2 is 6. Plus 1 is 7. And then 3 times 1 is 3. Right, we're now into the tens column. So we're looking at the 2. So we put our 0 here. And we got 2 times 3 is 6. 2 times 4 is 8. 2 times 2 is 4. And 2 times 1 is 2. And then we're into the hundreds column. Because we're talking about the hundreds, we need 2 zeros. And we've got 1 times 3 is 3. 1 times 4 is 4. 1 times 2 is 2. And 1 times 1 is 1. So now we can add this all together. We've got 9. We've got 8. We've got 7 plus 8, which is 15, plus 3 is 18. Carry the 1. We've got 4 plus 4 plus 4 is 12. So put the 2 down and carry the 1. 2 plus 2 is 4, plus 1 is 5. And then finally we've got our 1 there. So we've got 152,889 as our answer. Now, I'm going to write down 3 of these. I want you to pause the video and do them yourself. So question 1, question 2, and question 3. 123 multiplied by 13. There's our first one. 1,022 multiplied by 39. And our last one is 1,205 multiplied by 102. Okay, so do these questions, pause now, and then once you unpause, you'll be able to see me stepping through really quickly. Okay, to work these 3 out, we'll start with the ones column. 3 times 3 is 9, 3 times 2 is 6, and then 3 times 1 is 3. And we're adding on. We're in the tens column now, so we'll put a 0. 1 times 3, 1 times 2, and then 1 times 1. When we add these together, we get 9, 9, 5, 1. So the answer is 1,599. Second one, we have 1,022 multiplied by 39. So start in the ones column. 9 times 2 is 18. Carry the 1. 9 times 2 is 18. Plus 1 is 19. So 19, carry the 1. 9 times 0 is 0. Plus 1 is 1. Then 9 times 1 is 9. So let's get rid of these. We don't need those carries anymore. We're now in the tens column. And we're multiplying by 3. So 3 times 2 is 6. 3 times 2 is 6. And then 3 times 0 is 0. And 3 times 1 is 3. Now if we add this all up, we get 8. 9 plus 6 is 15. So carry the 1. 6 plus 1 plus 1 is 8. 9 plus 0 is 9. And we've got 3 there. So our answer is 39,858. Now last one, the fun one. We'll start in the ones column. 2 times 5 is 10. So we put our 0, carry the 1. 2 times 0 is 0, plus 1 is 1. 2 times 2 is 4. 2 times 1 is 2. Now in the tens column, we've got nothing, so our answer would just be 0. So don't stress about that. But now we move on to the hundreds column, and in the hundreds column, we do have a number. So hundreds column, we'll put our 2 zeros, and then we'll multiply them by 1. So 1 times 5 is 5. 1 times 0 is 0. 1 times 2 is 2. And 1 times 1 is 1. Now we just have to add this all up. So we've got 0, we've got 1, we've got 9, and 2, and 2, and 1. So that means our final answer is 122,910. Okay, so I'm hoping that you got those right. There'll be a few more questions in the exercise will allow you to practice that skill, but that's basically that multiplication algorithm. It comes down to, in your times tables well, and being able to step through the process without making any blunders. Okay, the second part and the most important part of this lesson is looking at mental multiplication techniques. Now, truly, this is the important technique. As you move up through the grades, there'll be less emphasis on you stepping through these algorithms, and really, this kind of stops this year. So it's kind of nice to know this, and if we really get stuck, yep, we can do this, but the intent is the questions we'll be asking, we're hoping that you can do the multiplication in your head. So there's a few techniques. I'll just remind you quickly what we do when we multiply by tens and hundreds and so on. So if there's zeros at the end. Then we're going to look at two techniques. As I've taught you for a couple of lessons, I already have an idea about which technique you'll like. I have a feeling that you'll like the algorithm approach. So trying to do what you do in the algorithm in your head, and that's okay if you have the working memory space for it. And my favorite is another shuffle approach. So I'm big on the shuffle approach because maybe my working memory isn't great, and I find it easier to adjust first and multiply. So we'll talk about those two approaches. First of all, we'll just quickly go over multiplying by tens, hundreds, and so on. Okay, so this one should be a nice, easy one. And again, I'm hoping that most of you are pretty happy with this. Obviously, the whole idea is that we move the decimal place by the number of zeros. And as we won't be playing with any decimals today, really the idea is that we add the zeros to the first number. Okay, so for example, 723 multiplied by 100, these two zeros join the 723 to make it 72300, or 72,300. We could also look at 57 multiplied by 10. Again, the same idea. The 0 joins the 57 and we get 570. It doesn't matter how many zeros we do with this type of thing. We could look at 1247 multiplied by 10,000. And all we're doing is writing 1247, and we're adding on the 1, 2, 3, 4 zeros. So that would give us, we've got 3 zeros, we've got 3 numbers, that would give us 12,470,000. Okay, so I'm hoping that's something that you go, yeah, well done, Mr. Pritchard, I know that. And now we're going to look at our two strategies. So we'll start with the algorithm approach because I just know that that's where you guys will find your happy place. So really the whole idea here is that you're trying to split up the multiplication without writing the whole thing. So you can write parts, but we don't want to write out the whole algorithm. Okay, so this is meant to be a quicker process. So let's look at one like this, 122 multiplied by 12. Now we could set that up in the algorithm, and I know that you guys know that we could split that up and we could think about it as 122 times 10 and 122 times 2. And so really that's going to be your thought process when you're doing this algorithm approach. You'll split it up and you go, I'll multiply by 10 and I'll multiply by 2. And if I join those two things back together, then I get my multiplication. So here we go. So we've got 122 multiplied by 10, which is 1220. 122 multiplied by 2, which is, we're doubling all those numbers. We've got 244. And when we put it back together, we get 1464. Okay. So hopefully I haven't messed up any of those additions. 4 plus 0 is 4. 4 plus 2 is 6. 2 plus 2 is 4. And the 1 stays there. All right, so that's the algorithm approach. And like I said, I know that most of you will be pretty happy with that. And in a lot of cases, it's just the easiest way to do it. So let's do a couple extras. So let's say 32 multiplied by 43, e.g. 2. Let's look at 14 multiplied by 37, and e.g. 3. Let's look at 123 multiplied by 35. All right, so first one. What's the easiest two multiplications to break it down into? We could probably say 30 by 43 and 2 by 43. Now, it's pretty hard to do 30 by 43, so the thought would be, forget that 0 for a second and think about what 3 times 43 is. So we want to triple 43. So 40 times 3 would be 120, and 3 times 3 would be 9. So if we put that together, we get 129. Now, we have to remember that we forgot about the 0. We'll put it back on. And now we've got 2 times 43, so we're doubling 43, and that will be 86. To put that back together, I'm going to use the shuffle here. I'm going to move 10 to this 1290 to make it 1300 or 1300 plus 76, so 1376. Now there's lots of mental calculations in there, so my recommendation with something like that is to use a couple of lines or use a few lines just to kind of step through your mental process, and as you get better at it, you can cut out some of the lines. Okay, we'll look at the second one. We got 14 times 37. So how do we break that up? I'm going to flip this around and think of it as 37 by 14. And that way I'll break it up into 37 times 10 and 37 times 4. So times 10 is nice and easy. 370, dump the 0 on. 37 times 4 is a little bit harder. I love thinking about multiplying by 4 as double. So every time I multiply by 4, I just double and then I double again. So if I double 37, I get 74. And if I double 74, I get 148. Right, so now we've done the hard part. We can just add these two things together. 8 plus 0. 4 plus 7 is 11. I can carry the 1. Then 3 plus 2 is 5. All right, now the last one, the mean one. There's two ways to go about this. I think the easiest way is to actually break it up and do it in 3 parts. So we can go the 100 multiplied by 35, the 20 multiplied by 35, and the 3 multiplied by 35. So here we've got 3,500. So we add the 2 zeros. We got 2 times 35, which is 70, because remember, we forget about that 0 for a second. And then we add the 0 back on, so we've got 700. And 3 times 35, 3 times 30 is 90, plus 3 times 5, which is 15, so 90 plus 15 is 105. Now it's just a matter of adding these back together. So in the ones, we've got 5 plus 0 plus 0, that's nice and easy. Next column, we've got 0, 0, 0, so that's nice and easy. We've got 1 and 7, which makes 8, plus 5 makes 13. We can carry the 1. And we've got 4, 3, 0, 5. Now, do you want the good news? The good news is generally we don't even do multiplications that are quite that painful in senior. Most of the time we're just dealing with small ones, but it's still a good technique because they might pop up and you want to be able to do them quickly. So it's a skill to practice. So in some cases, this is going to be the best approach. Now, the next one I'm going to show you is that shuffle approach, which is more an adjust approach. So we looked at it with addition and subtraction, and I'll be honest and say that I don't think you liked it so much. But sometimes with multiplication, it just makes your life easier, and I'll show you why. So let's look at 19 times 37. Now, I straight away look at this and I go, 9 times 37, that's going to be painful. So the way I like to think of it is 19 lots of 37 is the same as 20 lots of 37, take away 37, and it all of a sudden becomes something I can deal with. Or if I multiply out the 20 lots of 37, take away that extra 37, I still end up with 19 lots of 37. Now, these ones are good, especially when we're close to a tens or hundreds value that we can round up to nice and easily. So here I will go 2 times 37 is 74, and then we can put that 0 back in. So 740, take away 37, and that's a nice easy calculation for us. That's 703. Another one where this would be useful, let's say we've got 198 times 13. So I know that 10 times 198 and 3 times 198 is a little bit painful, but if I go, well, what about 200 lots of 13? And that means I've added in 2 extra lots of 13, so I'm going to take away 2 lots of 13, which is 26. So with that adjustment, 2 times 13 is 26. I can put my 2 zeros back on. I can then take away 26. And even though that's not the friendliest calculation, we can do that pretty easily. We can say that's 2, 5, and if we subtract 26, we got 74. So 2, 5, 7, 4 plus 26 will take us back up to that 2600. Okay, so there's our 2 approaches. I want you to try both, and I want you to practice, and the better you get at it, the hopefully more confident you'll be. But just like with the algorithm approach, it comes down to you knowing your timetables. If you don't know your timetables, then it gets really difficult. I've had students in year 11 and 12 that struggle with their timetables, and it just slows them right down. So now's the time. If you're not good with your timetables, go back and practice them. You want to know every times table from 1 times 1 through to 12 times 12. Okay. I will have set a couple of exercises at MathSpace for you to do, and basically go through, practice whichever technique you like. If you're more comfortable using the algorithm approach, then that's fine for now, but the goal is to move into being able to do mental calculations as quickly as possible and to move beyond those algorithms. Okay, thank you very much.